Good morning, everybody. Good morning. I'm Andrea Perego. In one team, I do lead the practice of innovation consulting. I'm here together with my colleague Riccardo to present you the ECOFACT projects. So, ECOFACT is a European funded project. It's a Horizon 2020 project. We're going to present this project through different steps. So we start with a brief introduction, and then we go for a project overview. Then we will deep dive into the solution itself, and then we will understand which could be the next steps. First of all, a brief introduction of our company. One Team is a consulting company operating in the consulting for engineering companies since 25 years. We are one of the top platinum partners at EMEA level, and we do provide the complete end-to-end IT solutions for manufacturing, architecture, engineering, construction, and GIS market. These are our key numbers. So we have a staff of about 100 employees. We have a lot of customers, a lot of users of our software solutions. Our overall revenue is more than 38 million euro. We are growing year on year, more or less 20%. And we have 11 locations. We have 11 offices. One of these offices is here in Madrid. Entonces, si quieres, hablamos español. So, as one team, we have been working in different European funded projects. These are some of them. So, three of these projects are focusing on buildings, and one of them is focusing on manufacturing. So, but the aim of this project, let's say our scope within these different projects is more or less the same, because we are always in charge to develop the platform to manage the data. So, a common data environment where to manage the data of the buildings or of the factories, it depends. So we basically develop the BIM-based platform or digital twin platform. It depends. It depends on the scope of the project itself. For example, in Bildon, we are working for a digital twin level 4. So in this case, we will need to control the physical asset from the digital one. In the other case, we are working at digital twin level 3, so just conveying all the data and the data deriving from IoT sensor, etc., in a digital twin, using this data for simulations, analysis, etc. We will deep dive into this solution later with my colleague Riccardo. Okay, let's go for a quick project overview. So ECOFACT is, as I said before, a European funded project with a 12 million euro budget. It started in 2020 and it lasted for 48 months. So the consortium is made by 20 organizations, and we are one of them for sure. And let's say, from our point of view, the core of the project is the digital twin platform that will operate as an energy and resource management system. And we will see later on what does it mean. So to start describing the project, it's useful from our point of view to focus on the objectives of the project itself. So at the very beginning of the project, we define the scientific and technological objectives of the project. We would like to focus on some of them. So, for example, the second scientific technological objective is to cut the factory energy bill by an average of 25%. And this is an important project, considering important objective, considering also the cost of energy nowadays. And as we will see further development of the project, we reach this goal. So also the third scientific technological objective is important. They are all important. Let's say from our point of view, also the third is relevant, because it aims at reducing, this project aims at reducing environmental footprint of manufacturing process by an average of 8%. And we will see how we go after this objective through LCA, LCC analysis. There are other scientific technological objectives. So to define a methodology for holistic manufacturing. So we will let's say, define best practice that could be used in similar factories, in similar industries. We want to reach, so the aim of the project is to develop a TRL7 digital twin platform and TRL7 ECOFACT platform more in general. So we will see also which is the difference. I think we all know what is TRL about. So technology readiness level is a scale up to 9. So 9 is a go-to-market, is a solution ready for the market. So our aim within this project is to reach TRL7, but we are pretty confident that this solution deserves to reach TRL9, and we will see why. So, besides, there are other non-technological objectives. So we are working together with UNE, so the National Institution for Normatives here in Spain, and we want to give inputs to define a new normative regarding manufacturing and sustainability for sure. Then we want to foster exploitation and replication, and for sure we are here for dissemination activities. So please, Riccardo. So the real protagonists of this project are the demo sites. So we are working with the discrete and continuous manufacturing in order to test our solution in different industrial environments. So one of these demo sites is Arcelic. It's a washing machine factory based in Romania. The other one is Tofaş, is an automotive factory of the Heineken Group based in Turkey. Please. Another, so for as far as regard the continuous manufacturing, we have Athenian Brewery in Greece. It's a brewery, so it's a factory of beer of the Heineken Group. And we have Gullón. Gullón is a biscuits factory here in Spain. So it's the largest biscuits factory in Europe. So let's say the schema of the project is pretty simple, pretty linear. So we want to take the data from these factories, leveraging from one side existing sensors in place, from the other side, putting in place specific industrial IoT. Please, Riccardo. Then we wanted to convey this data in a local data acquisition system. So basically, we will then pass this data through a data broker in order to collect, clean, and harmonize this data, and to distribute this data to an upper level, that is the level of application and services. So where there is our digital twin platform that will operate as an energy and resource management system. So what does it mean? The digital twin platform is kind of general way of define a platform. It's a platform where a digital twin is. In our case, alongside the digital twin, there are specific application and services that will help the final user to manage energy and resources. So energy and resource management system. What does it mean? We will see the detail of this application, but just to know the title. So we have production and planning, industrial digital twin, energy flexibility. We have energy disaggregation tool. So alongside this energy and resource management system, we have also an LCA, LCC bunch of application that will work together to do life cycle assessment, life cycle cost assessment, and altogether these two bunches of application and services will form the holistic decision support system, which form the overall ECOFACT platform. Okay. So to deep dive into what is a digital platform in a concrete way, I leave the floor to Riccardo, who is the project manager of this project. Thank you for your attention.
Thank you, Andrea. I work with Andrea on European funded project, as he said, and I'm dealing with the project management of this project. As he said, we are developing the digital twin platform, which is a digital environment based on a solid commercial software called Autodesk Platform Services. We organized this platform in 3 blocks, I will say. The first one is the one with digital twin models, which are basically 3D models done with Inventor, in our case, the Inventor solution, but Inventor can host a different format of data. These digital twins are accessible through the Autodesk Platform Services viewer. You can see the real-time monitoring of the data coming from the sensor and also the historical data sets, because in our 3D models, we integrated, of course, the position of the sensor down the production lines or the machinery that we modeled. Then we use also this section to visualize the graphical outputs of the tools, the simulation and optimization tools that we integrated into this environment. And we also can host relevant documents of the factory. The energy and resource tools are those simulation and optimization tools done by other partners in the energy and resource management system, integrated by us of one team. I put in bold Optimist, which is the energy flexibility tool, because it is very interesting and you will see some good results obtained by this tool. But then we also have tools for material flow simulation and production planning and scheduling, energy models, which are done with Transys, and predictive maintenance, which is PDM. And in the end, we have the industrial energy segregation by product. We also have the data exchange layer, in which we leverage the API of the Autodesk software, but then also we have the authorization, the resource, user API, and also the model to connect the digital twin part, and also the API for the external tools, because the integration are pretty different between the tools. Here in this video, you see the environment of our digital twin platform. We have the 4 demo sites that Andrea mentioned: Athenian Brewery, Arcelic, Tofaş, and Guglion. We have the toolbar on the left to select, for example, digital twins. You are seeing the 3 models, the 3 production lines of Arcelic. This is the viewer of Autodesk Platform Services. We have the sensor on the right, and from the toolbar we can switch on and off the sensors. You can move, as of course, platform developer, to other sites. We have many models for Tofaş. Tofaş, as you can see in the production line, you see the vehicles, the vehicles that are being painted, and you also have a pretty different sensor of the production line. Then we have Guglion. Guglion is the biscuit factory in Aguilar de Campo. We have 4 lines. 3 of them are into one assembly, and you see also the electrical, thermal energy, the compressed air sensor. And then we have Athenian Brewery. In Athenian Brewery, we have the machinery. We do not have the production line, but they are relevant. I mean, for example, this CO2 evaporator, it is very important because we are working on it also for the predictive maintenance and to reduce its energy consumption. You see that you can access the real-time monitoring In this case, it's a 3-hour time interval. You can also then select the time period for the historical values. Okay. And these are the tools that we are integrated. As I said before, there is Optimist, which is based on CBC for the energy flexibility, but it is also used for the optimized management of the existing generation assets of the plants. Then the material flow simulation is based on another commercial software, which is Siemens Plant Simulation Tool. The production planning and scheduling as well is based on the Gurobi solver. Then the energy simulation is based on Transys with energy models. And then we have the cost optimization part, which is basically the predictive maintenance. In closing, there is this industrial energy aggregation performed by product. Okay. This is the Optimist tool, and it is very interesting because it is applied in 3 different ways. The first one is to minimize the product changeover in the production line, because one production line is used for different items in a titanium brewery. For example, there is the production line for the bottles, for the kegs, and for the cans. But there are many kind of bottles, and it reduces the changeover times. It is also used with different algorithms to minimize the electrical energy bill, and it can do this using the photovoltaics, and depending also considering the energy tariffs, and it adapts production. It is used like this in the Arcelic plant for the washing machines. Also, it can minimize the energy bill, and it does so optimizing the management of the existing energy assets. And this happens in Tofaş, which has an enormous amount of energy spent for the body painting of the vehicles. The outputs are production scheduling for a titanium brewery and Guillon, the 2 continuous event manufacturing demo sites, a production scheduling also in Arcelic, and an energy production scheduling in Tofaş, with also some economic parameters in output. Okay, these are the results by this tool that are pretty relevant, because when the tool is used to minimize the changeover of the product in the production line, it gives not only benefit in terms of changeover time, minus 13%, but also benefit in terms of energy, because if you use less your line, then it means that you are also consuming less energy, less liters of water to produce the beer, and also less CO2 emission, minus 13%. Instead, when the tool is used to minimize the energy bills, you have minus 20% of gigawatts hour per year, and also a reduction of CO2 in terms of tons from minus 4 to minus 6. As a consequence, using the minimization of the changeover time or of the energy bill, or a combination of both, you have benefit in terms of euro per year that can go from just minus 9,000 euros up to, in the case of Tofaş, the plant for the body painting of the vehicles, up to almost 1 million euro per year, which is of course very relevant those days with the energy tariffs. These are, let's say, 2 tools, because you have the material flow simulation based on Siemens and the production planning and scheduling based on Gurobi solver. This output that you are seeing on the left, you can see it on the digital twin platform, and it basically is the kilos of painting for the vehicles that you save using this simulation and optimization for every 13 minutes. The unit is kilos, basically. And you see that between the outputs you have this paint saved for the vehicles, and also you have the scheduling of 2 lines for Tofaş, like for example to see when starting the line, basically. And in the case of Arcelic for the washing machine, these two tools gives a production scheduling, and also it says with that production scheduling how much energy spent. These are two tools as well, but I don't have the result yet for the energy models, which are based on Transys. Instead, we have the results for the predictive maintenance. On the right, you are seeing one of the Tofash lines of the production lines that we have, and you see highlighted in blue 9 components, which are basically air supply units. This partner did the predictive maintenance on that on those machineries, and we basically give them, the end user, the possibility to see the result of the predictive maintenance. The results are basically the forecast before the maintenance to be done and the cost saved. And considering all the demo sites, I condensated all the results. The cost advantage goes from -3 to -11%. And the forecast of days before the maintenance, obviously, depending on the machinery or on the machine, can go from just 11 days up to 600 days. Consider that predictive maintenance is always better than the corrective maintenance and the preventive maintenance. Okay, Andrea? Thanks. This is the last of the tools. It is the industrial energy disaggregation byproduct. It forecasts in terms of energy, and as output you have these resources that you are seeing disaggregated by product. Therefore, the resources are electricity, compressed air, natural gas, and 3 kinds of water, including fresh water. The product in this case is Tofash. Therefore, you are seeing 3 different vehicles, like kind of the Fiat Egea and the Fiat Doblò, for example. And now you see that from the digital twin platform here, we are focusing on electricity. The different vehicles are represented by the different colors per each day. And in yellow, you see the energy that is saved producing the different item types. It means the different cars together and not individually. Okay, Andrea? And this is the last video. Okay, one more click. Okay. And in this video, you are seeing some of the tools. I am focusing in this case on the Optimist tool. Remember the one of the energy flexibility. This is the graphical user interface. The staff of the factory put CSV files or values in input, which are basically fixed. And then you run the tool, and you can see a production scheduling, which is the one required by the Titanium Brewery factory for the different lines, cans, kegs, and bottles. And you can also see the graphical output on our models. The digital twin model that you're seeing is a keg machinery, and you can see, for example, the output of the bottles or the keg line. The different color mean the different kind of kegs or bottles items. The space between the rectangles is the change over time, which, if you remember, is the parameter optimized. Then we are moving to, it is always Optimist. No, in this case, sorry, it's the predictive maintenance tool. I want to show to you how it works. Basically, you have the result, like the cost saving and the graphical output. This same graphical output can be viewed for the specific machineries. These are air supply units in our Autodesk environment. And it is always, this platform is going to be used by the industrial staff, basically. Okay. What's next? In the next slide, you are seeing that now the project is in its month 33, and it will last at least until month 48. And the next project target is to basically bring together our work on the digital twin platform, in black, the energy resource management system, and the LCA and LCC analysis, which is done by another partner called Perego Sustainability, into a single dashboard, which will be the dashboard of the ECOFACT platform, because our digital twin platform is just a module of this holistic and bigger ECOFACT platform. Basically, we also for the exploitation, we are pushing a lot because the TRL we will reach is 7th, but there is a huge potential from our point of view with this platform and the algorithms that we integrated. We already have one demo site for exploitation, which is a huge company in the United States. They were interested in the solution. Therefore, we are looking for other 4 demo sites, and the planned marketability of the solution can happen in 2028. This is just a forecast. Hopefully, we manage to do it earlier, and that's it. If you want more information, you can drop an email to us or just follow ECOFACT on the social.
Yes, maybe I just want to add that we already have a very huge customer that is Gallo AJ, that is the biggest winery worldwide, that already signed an NDA with us because they want to test their solution on their factories.
Yes, more specifically, the algorithm that you saw from the Optimist tool, in which the changeover times are optimized and you have benefit in terms of energy and CO2. The reason is that they produce wine in their bottles, which is the same of Athenian Brewery with Heineken. They produce the beer in their bottles. It is very similar. And of course, all the monitoring part of the sensor from the field with the 3D model, which is also interesting for them.
Okay, we leave the floor for the next speaker. Thank you. Yeah. Okay, no. I don't know. But...
Yeah, I have a few. So.
Okay.
Okay, you have mentioned a few times out of the service platform. Is this platform for service? Is this a decision of the consortium or is your decision? Because like you said, work with it or was it of the integration with vendor and models?
Yes. So we define it from the very beginning. In the other project, we do work on open source and we do develop from scratch basically. So in this case, considering the TRL and where we want to arrive, we decided and stated from the very beginning that we would like to use and leverage Autodesk platform services. It's not a solution. It's a platform. So it's not Revit or Inventor, or it's not as I say, end-to-end tool. It's a platform where you have to develop. So basically, it's just facilitating development because you already have some predefined APIs, etc. So it's, let's say, easier to connect, to manage models, etc. But yes, to answer your question, we decided from the very beginning, and from the proposal, basically, to use this platform considering the scope of the project and the TRL.
I have a few questions more. I saw that you are relying in a lot of 3D models. Have you ever considered the idea of using like virtual models, like let's say those one taken by 3D cameras, like let's say a kind of point cloud format in which you can also navigate instead of modeling it and spending time modeling? Probably for some cases it's not possible because you need more detail, but for a general overview or for specific things, this is something that can be made in the States and can be taken.
Okay, I will start then, Riccardo, if you want to add. So this is a very, let's say, interesting topic. Thank you for the question. We have this morning a webinar on this topic together with Leica on how to manage point clouds and how to translate point clouds in a model. The fact is still there isn't, let's say, a mature technology to do it in a parametric way. So you can translate, let's say, the point cloud in a in a model, but not in a parametric model, no? So let's say that for our aim, we should have a proper digital twin. So let's say a parametric digital twin, so that you know, if you change anything in the future or whatever happens, we could, let's say, change it from the parametric model. So yes, it would be it would have been easier maybe to just get the point cloud result and put it in the digital twin platform. But we do think that for now, as per today, modeling still is necessary. We are working not in this project, in other projects, on how to, let's say, match point cloud elements with BIM libraries. But the starting point is that you need to have a library. So I need to know this desk, which desk is this chair, which is. Then I can do the matching, and we are working on this automation. So how to automatically match the point cloud with the BIM library and recreate the model in a, let's say, semi-automatic way. But in this case, you know, are huge factories with different components, so it's not that easy to do it. I don't know if...
Like, just can add that for some machinery we use the Leica BLK 3D, but just for some machinery that the factory wanted to have them modeled a bit better. Otherwise, we started from the DVG files or photos, Excel details, something like
yes,
this.
Let's say that for the aim of the project, it's not necessary, let's say, a predefined level of definition of the model, no? But the idea is to have the possibility to use this model for different scope in the future. So the ECOFACT platform is, let's say, a starting point. So you have the model, you can connect the different application and services to take data and do simulation. So we don't know where we will arrive. So I think it will be a dynamic development. So let's say having a parametric model is a value, because with this model, with this data, with the geometric data, you can do more and more, and from the model itself you can navigate the model, you know, access, take measurement. I don't know if we show it in the video, but you directly in the model you can click, you can see the details of the specific component.
You can even navigate first person line, but it is a functionality offered already by the Autodesk engine. Yes,
you can take measurements. So yes, we think that having a parametric modeled it's a value.
I don't know if you have more time or if you have it. Okay. Well then, I saw that you were using weather data. That it was for the predictive maintenance. Why?
We are not using them directly, but some partners are considering them. I know for the Optimist tool as well, for the energy flexibility and the optimized management of generation assets. Then I know that also for the energy models, we do not have the results yet. The energy models are those based on trances. They are also considering the temperatures, like for example, as input to then run the tools. But we are not using them directly. Let's say that the integrated tool, graphical user interface, whatever, already consider this weather data. Sometimes they are used to train the model, sometimes as input defined by, for example, the staff, but in most of cases they are, for example, fixed, or they can select just small intervals of temperatures. It depends, I mean.
I also saw capacity building in one of your presentations. So are you working also with the workers of the factory in order to reskill them, or what you are doing about capacity building?
We have worked with the factories. In our case, it was for the modeling, because we had one person that went to the factory to define the modeling work, and also all the partners went there to define strategies. It was not easy sometimes to have all the necessary data, because in some case they generated synthetic data, but if you want to add for the capacity building.
No, yes, I think that I don't know if I understand well your question, but we are kind of think about involving the users at a further stage. So let's say not at the further stage in the development, but mainly also at the further stage to test the solution. I don't know if this is the...
Yeah, it's basically because, well, normally this kind of platforms implies some changes in management, but also in the workers. On them we need to skill, or we need to learn some things in order to operate, and then so that we work in capacity building. So
yes. Then there are different partners developing different applications. For example, I know that as far as regard predictive maintenance, our partner that is CERT is working very closely with the Athenian Brewery team. So to be honest, I think it depends on the different tool, on the different partner. So, but for sure, this is key for the success of the solution, because what we are experiencing, since we are working more on the platform as a whole, is that involving them to get feedbacks on the also interface, if it is useful, etc. is vital. So then you're right. Then there is another level of working with the user that is day by day, making them learn how to read predictive maintenance output, etc. This is something that the partners are doing with the specific demo site, and that will need to be done more and more.
I would say that the main scope here is to have the integrations done that can be reused even for other sites, and instead, even if you consider the digital twin models, for example, of the Tofaş factory, we have almost all the plant for the body painting modeled. In that case, even when we finished, then the demo site came back to us saying, "Oh, we would like to remove some sensors because they were sensor planned to be installed, and we just updated, uploaded to the platform a new version of the model," and it was kind of. I'm thinking it's kind of a situation which we'll have in the future. For example, if you have a customer that want to change some details, we have still the .yam model of Inventor. We change the details and then we kind of easily upload it to the platform. Or as Andrea was saying, considering the other partners, the integration is done. I mean, it will happen always in the same way, even for other demo sites. But if you take the same ECOFACT demo sites, maybe in the future there can be some retraining of the models of the algorithms. And then in that case, the tools, for example, the graphical user interface will not change. It's just the training happening, I would say, in back end that changes, but the graphical user interface, the front end remains the same. What is going to change, it will be the output or the result, but also the output, even if the output are complex, are outputs that are defined together with the demo site. The demo site knows how to read the output, even if they look very complex, but it's what the demo site want to see.
I have a few more, but I save it for later, so thank you very much.
Thank you for your question.
Thank you.
Can I answer just a very short one?
Yes.
You have exploitations. You are looking for demo site?
Yes.
Exploitations, what type of demo site are you?
Yes, let's say that basically the tools we are developing are pretty, how to say, customized. So the best in class will be to involve demo sites with similar business model, no, similar industry, similar manufacturing processes.
Basically the same typology.
Yes, I mean it's not written in the stone, but for example, as I mentioned before, we involved Galway J. This is a demo site with similar processes because at the end of the day, making beer or making wine is different the taste, but
Yes,
at the end of the process is the same. So
At the end, it's your company, the main owner of the innovation from this project.
let's say we have a specific key exploitable result that is the digital twin platform. And then there are other key exploitable results that are, let's say, also related to the different tools. So depending on the tools that we want to use, but let's say that as far as the digital twin platform itself, we are developing it.
Just to add to what Andrea said, regarding the key exploitable result, the digital twin platform CARE that he mentioned is the one with all the partners inside of the tools. And even after the beginning of the project, the Optimist tool that we see is very good tool. He was saying that we defined it together with that partner a separate key exploitable result for just our platform and their tool, in order to exploit the solution together, and we can do it even in the ongoing project. And we can do it, for example, even for other tools. And one thing also to the exploitation of the solution in other demo sites, for example, can be also demo sites, industrial demo sites that have a lot of energy assets, because there is one of these tools that it is just applied because the Tofaş factory has so many energy assets to control, in which they spend energy or they produce energy. Therefore, you can have a factory like this even if they not produce car, even they produce something which is different. Then, of course, as Andrea said, the best thing anyway is to have demo sites with similar scopes, of course. But it's pretty different, because you have the continuous manufacturing with biscuits, food and beverage, basically. And then on the other side, washing machine includes so many different parts, and it can be, for example, you have the drum, you have a cabinet. There are many different pieces assembled together, and I think that if there are some tools specific for the archery washing machine, then they may work also for even different products, I think. Okay.
Thank you.
Thank you.
Thank you.
Can you just do a photo for our dissemination partner? Yes. Thank you. Thank you very much. Otherwise, he will not believe us that. Thank you.
Thank you very much.
Thank you very much.
So you're 6, back from 0?
Zero. Yeah.
Okay. Do you want me to come for you or
No.
you prefer?
Thank you.
Okay, so good morning. And so this is also a presentation of a new project, which is called Platform Zero. This one is just beginning, so it's I won't have so many results to present, while yours was close to the end. And I'm Regis from the French branch of R2M, so also R2M, which is organizing this event. And in this project, actually, we have two branches of R2M involved, France, and also my Italian colleagues are also here. So we are both involved in exploitation and dissemination activities. So we share those tasks in this project, which is about zero defect manufacturing, focused for the photovoltaic industry. And especially, let's say, the next generation of photovoltaic devices. So it's a project which is part of the partnership which is called Made in Europe. I don't know if ECOFACT perhaps was the same. And it's linked to an association called EFRA, and I believe that they support a lot of projects around this topic. So this is the partnership. So we have 12 EU partners. So it's quite a compact consortium. And again, we just started. So that was the picture from the kickoff meeting just a few months ago. And so basically, we have a good mix of research centers. So IREC in Spain, in Catalonia, is the coordinator. And we have AIT as well, and basically the research centers, they bring really their knowledge on spectroscopic methodologies, on imaging, and also artificial intelligence is a key component in this project. And it's a key innovation which will be implemented to optimize the manufacturing process. So yeah, we have research centers, we have universities as well, and it's also a very industrial consortium because we have with us owners of PV manufacturing lines in which we are going to implement the innovation. So we have 4 demo sites, which will be later in this presentation. So again, we are focused on solar photovoltaic. And perhaps here I can make a short parenthesis about our company, R2M. So we, at R2M, as you know, we have half of the activity which is on research on projects like this, but we are also on the market, just like our name indicates, and it's research to market. And with regards to photovoltaic, we commercialize BIPV solutions. So we commercialize photovoltaic glass, in fact. So it's glass which is producing energy, and indeed there are many interesting innovations like this in the photovoltaic sector, but they are more complicated to design, let's say. And the problem is that usually they are customized. BIPV products are customized for every project, and therefore there are a lot of defects when manufacturing those innovations. So that's why. Let's say that for us as a company, as R2M, this project is really an interesting one. So solar energy, I believe in the EU is quite growing. At the moment, it's a kind of easy to deploy renewable energy, which is quite well handled. There are many quite a solid value chain, let's say, to implement that. But indeed, in this project, we mainly focus on what is so-called third generation PV technology. So I mentioned BIPV, which is again photovoltaic integrated in buildings. That's what we do at R2M. But there is the same thing, PV integrated in vehicles, for instance. So it's really and also in boats and in many different applications. So we yeah, agriculture as well, agrivoltaics. That's also something which is quite, at least in France, so there is a big push for that. So yeah, many different innovative applications with photovoltaic, which this project is going to support. But again, more complex to manufacture, and the interest of platforms. So that's what the project will do. It will develop a tailored inline process monitoring platform supported by artificial intelligence with the objective to achieve, again, zero defect manufacturing for the PV industry. And again, we have 4 industrial pilot plants in Europe to test this. And so the impact is to, of course, to decrease the cost of fabrication of those modules, and also to improve the quality at the same time. So this is the, let's say, really the macro overview of the methodology which we are going to implement. Again, we are on the left-hand side at the very, very beginning. So at this stage, we are, the industrial partners are designing some reference samples of the innovative PV, which are going to be tested with this innovative manufacturing line. In parallel, some other partners are working on the artificial intelligence algorithms, and there is also a big data platform to handle all the data outputs which are going to be generated. So that's another component, which is the one in orange in this figure. And so mostly focused, let's say, on technology development at this stage, and then we will move to the implementation into the demo site a bit later during the project. So this is the timeline, again, which is a bit more detailed, but we are just beginning. Yeah, we hope to have a first generation of the artificial intelligence module by mid 24, and then that's the timeline until the very end of the project, let's say, which is mid 25, when we hope to have these innovations implemented. So I believe in terms of TRL, we are aiming to reach TRL 7, so it's quite similar, in fact, to ECOFACT. And these are the pilots. We have one in Spain, which is led by a company called Luredera. And you see that each pilot is, so everything, of course, focused on PV, but each not exactly the same type of PV module, and not exactly the same type of technology. So we aim at a modular innovation, let's say. So Luredera in Spain, one pilot in Germany, so this one will be more on CIGS modules. One in Austria with a company called Sunplug, and then one in Poland, led by Sol Technologies. So this one will be focused on perovskite. So I'm not sure if you are familiar with that, but it's one of the latest generation module, which has a very high power. So these are the macro objectives of the project. So there are 5 main objectives, and the first one is focused on the development of advanced sensor stations. The second one is on the artificial intelligence system. The third one is on the big data management, infrastructure and control system. And number 4 is the installation of the functional process monitoring platforms to collect all the data. And finally, number 5, it's the overall optimization of the manufacturing process. So that's the overview, and basically that's just the representation of a PV manufacturing line. And in colors, you have the different, let's say, innovative elements which we are going to implement in this project. So these are the outcomes, or let's say the expected outcomes, because again we are just beginning. So we hope to overall, of course we hope that this project will boost the overall PV industry. That's the aim. But more specifically, again, we are focused on zero defect manufacturing. So really to decrease the number of defect on the modules production, a better diagnostic of the deviations during the manufacturing process. And in terms of numbers, so it might look a bit modest, but at the end, if you consider the overall PV industry, it's a large impact, in fact. Like a 10% increase in productivity could be a great achievement. And also the decrease in consumption of raw material is very important as well, because like for perovskite, it's those materials are quite expensive, and even a small difference in terms of a small optimization of the manufacturing process can have a large impact in terms of reduction of the cost. So again, and these are the, let's say, the more detailed KPIs that we have, but more to monitor at the project level, and also for each technological component, how we are going to be efficient in this project. So this is it. That's the partnership, and we just have released our dissemination material. So we have a website now, so you can follow us. And again, if you know someone who is active in PV manufacturing, I recommend you to follow this project. I believe it will be we will have really interesting results in a few months. That's it. Thank you very much.
This scheme for civil detecting manufacturing is very interesting. But I wonder if you have just thought of linking this manufacturing process with the quality management team. Because nowadays, especially thinking about huge production plants, like hundreds of megawatts and all stuff. So it will be very, very interesting to have the overall value chain control with this manufacturing perspective. Specifically thinking about companies like PI, Berlin, and all these quality assurance and quality control value chain companies.
Yeah, no, that's a good point.
Because this system could, at a certain point, generate like quality specification and insurance documentations or certifications or something like that.
Yeah.
Before the transportation, and to have the overall team full covered. And minimizing the.
Yeah, you're right. Yeah, it's a good point for us to think about that. So for at least for me, I'm new to this kind of manufacturing project. So also, and we are in charge as always as R2M of the exploitation strategy and so on. So this is something personally I will discover a bit. But so this project is fully focused on photovoltaic. But I believe you are probably right. Yeah, in terms of exploitation, we can think a bit wider, probably, in terms of where these innovations are going to be applied. And again, in September, we will be in this EFRA day, where I think, Rubén, your project as well, STAR, is going to be. So I have the impression that, in this call, in this topic, we have 3 sister projects, but they are on completely different topic. They are not on photovoltaics. So I have the impression, indeed, that it's very diverse, the type of applications that the project they support are focused on. So we'll see that.
And I have a question for the monitoring platform. Is it an existing platform, or is it developed from scratch?
It's from my understanding, so it's a partner which is it's the one I believe they are in Germany, called the Risk Software. This T1, which is in
Risk. Okay.
yeah, this one in blue.
Okay.
And indeed, it's going to be more a tailored thing. Software development company. So indeed, they are going to develop really something ad hoc for this project, let's say. But of course, starting from a system that they have already implemented, so they will customize it. But I'm not sure if they are so much. It's really
But
yes.
they have an existing base.
Yes, exactly.
Okay.
Thanks a lot.
Hello, good morning. My name is Rubén Alonso, and well, I work for R2M Italy. I am going to present one project related to Industry 5.0 that is called STAR. I will start with the presentation of the project, but then I will focus on the part related to the human centricity and the worker reskilling that we are working on in the project. So, well, this is the title of the presentation. STAR is a joint effort of 15 companies across Europe. Basically, it's about human-centric artificial intelligence systems for manufacturing. We have a few pilots, we have also digital twins, some cyber defense mechanisms, because the idea is also to work in things related to how artificial intelligence systems impact in the manufacturing. And well, this is more or less the distribution of the partners across Europe. What is our vision in STAR? Well, the idea is to be the reference and the catalyst for security and safety human-robot collaboration in industry. And, well, somehow demonstrate the transition from Industry 4.0 to Industry 5.0, in which the human centricity is one of the key topics. The things we did in the project, well, we covered different aspects from the systematic requirements in manufacturing. So this means co-creation workshops with different pilots. This means having a reference of use cases. This means state-of-the-art of trusted artificial intelligence technologies. We did also some analysis on the legal impacts, so, and also standardization frameworks, having some, let's say, some base for the developments in this topic. Related to the more technical research is about the human-robot collaboration, things related to NLP, things related to multimodal interaction, active learning. So these are part of the project. And there was a specific topic about artificial intelligence and the impact in cybersecurity. Explainable AI, integration, how to rely on blockchain infrastructure, and some, well, also some analysis in different kinds of attacks, like positioning attacks and several attacks on artificial intelligence models. Yeah, the last collection of activities are related to safety. So this involves collaboration between humans and the robots. So there are some possibilities, or let's say have some impact in the humans. So we analyzed also the potential issues that this cooperation could have, and we had 3 pilots: one in Germany, one in Portugal, and 2 in Germany, 1 in Portugal. We are quite active in dissemination. We wrote this book. It has been downloaded more than 30,000 times, and well, it has been quite success. And it's about the artificial intelligence in manufacturing. We are writing a second book now. It's going to be published with the Springer in a few months. This first book was written by start partners. The second one involves several sister projects, so all coming from the same call. Projects involved that will be participating in EFRA, and so you will probably have the chance to talk with some of them. Industry 5.0, one of the difference is that the human centricity and the involving human in the middle of the manufacturing or in the collaboration with the machines. We like a lot this image and this description. It was taken from a paper. You have the source there, because it links the factories with humans, but also with sustainability. So it covers a little bit of this conference, but also part of this session, and things related to artificial intelligence, to smart factories. The idea of human centricity in Industry 5.0 is, well, having the human factor in the center of production, prioritize the well-being of workers, empower operators, but also improve the skills and the competences. The objective is to have a more sustainable and resilient production system. The part on improving individual skills and competencies is underlined because it's the focus of this presentation. We have been working on this part. So changes in the Industry 5.0 means that there are some workers that will need to learn something new, adapt to new functionalities, probably reskill to different activities. And some of them, I mean, they need to start understanding the competences they have. So we have developed a platform in order to do a few things. One thing is the tech skill gaps. This is not only for the worker, but also for potentially for the company. Provide career developing and capacity building, let's say, paths with some trainings, with some skill or knowledge acquiring recommendations, and also some upskilling and reskilling for continuous learning. The platform follows a privacy by default and privacy by design approach. Of course, there is a lot of data of workers there. The idea is that this tool is for the worker, for the use of the workers, not for profiling workers. So the idea is that the worker is the one that does the assessment, evaluates himself or herself, and gets some recommendations. It's multimodal, it's multi-sectorial. So we started in manufacturing, but the idea is that this could work also in construction, in other sectors. And it's based on well-known competence databases. So initiatives from the United States Labor Department, the European Commission, the Labor Department of Canada. So there are different databases that are well-known, are almost considered the standards, and we are using them, relying on them for understanding the needs of the workers. In the top right, there is the definition of the United Nations about what is capacity building. So basically, it's the process of developing and strengthening the skills, instincts, abilities, processes, and resources that organizations and communities need to survive, adapt, and thrive in a fast-changing world. And we rely on this also on this definition. So in practical terms, what things are we doing? So we developed this virtual interviewer. So it's a multimodal platform in which a user can go there and interact with a chatbot, with voice, with the keyboard. And it has also support from a conversational agent. So you can have a kind of a conversation with the bot. And with this information, so the information of the interview
perform some transformers, some artificial intelligence models in order to compare what the worker has provided with the reference databases. And with this, we provide some recommendations. We compare the results with the baseline, so the baseline provided by the databases, by the ONET or StarNet or ESCO, and we provide some recommendations in terms of, okay, what would be good that you learn, or what is your best path if you want to switch to another position. So this is the thing we do. We have also developed a chatbot. This is a chatbot in order to allow workers to learn contextual information about activities and occupations. You can ask questions like, what are the commonalities between this position and this position, because maybe you are considering applying for a different position, or you are considering to skill in a different position. You can ask what are the usual activities that a person doing this specific job does, in order to see if you are more or less doing the same things. So there are plenty of different options. We even have an open domain capabilities in which you can ask whatever you want, but the idea is that this is just for getting context about occupational information. Now it's more uncommon the use of ChatGPT and this kind of large language models for getting this kind of information. The benefit of this approach is that we are relying in something that is more or less standardized or well known. So the replies from the chatbot are deterministic. Normally, it is something that is not happening with ChatGPT, in which the answers can be dissimilar. You ask the same question 2 days, and you can get some different recommendations. In this case, we rely for let's say, for the questions that are related to occupations, we rely on databases in public databases, and for the open domain, we rely on large language models. Then we have a self-assessment for the worker in order to detect gaps in abilities, in knowledge, in work activities, in tasks. Allows to detect to compare with the baseline and to get some upskilling recommendations. And the last thing is to integrate with online course platforms. So we provide to the user the possibility to, okay, you are missing this specific skill. There is a course in Udemy, in Coursera, that covers this course. This is our recommendation. And also this recommendation engine can be trained with in-house materials. So you could even recommend something that was developed internally, or some materials, some manuals, or whatever you have in the company. This is more or less what we did in Start, related to worker training platform. And here is the approach that we are following in R2M for capacity building and skilling methodology. We have now in R2M an area that is called Industries of the Future. So it's not called Industry 4.0, it's not called Industry 5.0, because this is continuously evolving. It's called Industries of the Future. And we are covering, as part of other things like digital twins, we are covering also things like synthetic data generation, data augmentation, artificial intelligence manufacturing. One thing that we are covering in this area is the capacity building and skilling methodologies, mainly for workers, with the idea of human centricity, having the worker in the center of the production. but also applicable to other sectors. We have been discussing with the schools, with different public bodies. There is different, I mean, at the end, it's an skilling methodology. This is supported by a skilling methodology we have developed it in-house, based on some information developed in the European project, relying in databases, in well-known and standardized databases, with let's say, with a different kind of assessment, doing different, by using different methods in order to provide the skilling capabilities. So this is one of the things we are doing now in the industries of the future area. And that's all from my side. I was quite quick, but I think that since in the first presentation it took a little bit more than expected because of the questions. I don't know if you have any question or how. Yeah. Okay, perfect.
I read many calls with the Industry 5.0 topic in the center, and it's very complex, and I'm struggling to understand how to apply this topic to, for example, what we are doing in ECOFACT or what we could do in further projects. And I mean, my question is, how do you fulfill the requirement for the Industry 5.0 to have the people in the center? You said about the training, but is it kind of a manual on the digital tools for the worker, and is it kind of a deliverable? How is it?
Well, we do several things. The one thing is understanding with the workers in co-working session with them the impacts. So the impact of the digital change, of the evolution from the traditional industry to Industry 4.0. This is one thing we do. The second thing is to provide this kind of materials. So there are materials, there are websites in which you can go and see how it impacts, because this is relying in something that in database that the United States Labor and the European Commission has made to 100,000 of workers. So it's based on interviews. They have, let's say, aggregate the data and generate a kind of a baseline explaining what occupation is related to some activities, to some knowledge. So this information is more or less there. It's not valid for all the countries, but at least you have some information. This allows you and the worker understand what are implications. So so with this information, the worker can know how something can impact and how one functionality can impact. Then we are working a lot in explainability in artificial intelligence. Explaining, because it's not only providing the result, but also trying to provide the worker a way to understand what is happening. Because the knowledge is still, some of the knowledge is still in the worker. So even if the model provides something, probably if you explain why, there is a bigger chance that the worker can or understand what's happening, or maybe solve a potential issue, or ask you to retrain the model or whatever. But explainability is one of the key parts. And there is one part that is also related to safety, the one that they have mentioned. There are some impacts in the collaboration with robots, collaboration with machines, in which we are also doing things. And this is also based on interviews with the pilots, interviews with the workers. We have like 6 or 7 different co-workings and co-creation sections. We do workshops as many times as we can. Sometimes it's just with workers, of the time with associations. We did one, it was 1 month and a half ago in Netherlands, in North Netherlands, with Philips, which is involved, people from Philips, also from association of factories of the northern Netherlands, So we try to do this kind of this, and we have a few universities working on human centricity. So it's also improve the quality of.
You also mentioned the platform dedicated to the workers, right? And I'm okay. Maybe I understand. This platform is the website with the impact. Is it?
No, we are deploying probably next month a platform in which the worker, it will be public, it will be inside the Start website, in which anybody can go there and do a self-assessment. We did not, in this case, we did not restrict the occupation to manufacturing, so it's open for everyone. We are doing a kind of a validation. So anybody can go to this platform, do the virtual interviewer, so you can talk with the bot. So this will be open. The part related to the chatbot will be also there. So the chatbot to get information about different occupation activities, skills, knowledge, this will be there. And we are also recommending some training materials, some of them generated in the project. And we generated a guide for human centricity manufacturing, and this is one part of the platform also. It's just a document and a questionnaire, but it's part of it. And we are finishing it, and the idea is to have the project end of July, because we wanted also to have some. The project is ending at the end of the year, and we wanted some months of information also to validate the functionality. The TRL is not so high. I mean, we are 6, something like that. The idea is to continue growing, and also depends. As I told you, this is it's mainly for manufacturing, but depends on the kind of the client. So maybe you would have to adapt to some schools. Maybe you need to change the recommendation because it's not to them. You need to retrain the models with other kind of information. So it needs some adaptation. So we are working on it, but it needs some adaptation.
You anticipated my last question. Who is the final user of chatbot? Anyone.
Anyone, mainly for manufacturing in this case, but I mean in ESCO and in OStarNet, I think that in total there are more than 1,000 or 1,000 something different occupations described very detailed. So in some projects we restrict only to the ones related to manufacturing.
Yes.
But for instance, the chatbot and the interviewer we are deploying, at the end, we decided to remove the limitation and just open to anybody. So even if you are from another sector, you can self-assess yourself. The recommendations, well, in this project are more related to manufacturing. So maybe the courses you will get we don't have probably courses for aerospatial engineers because it was not, but at least you can see the functionality.
Okay, thank you.
Okay. Yeah.
Regarding the application of this construction, in Spain, this presence of human is like less than 2%.
Yeah.
Do you think in future calls or proposals to be possible to adapt this kind of economy specifically? Because I don't know exactly if there was this reporting, so the reporting on capacity development specifically applied to construction. It is a really, really huge issue for the construction.
Yeah. We considered that because construction is one of the less digitized sectors, and there is a lot of need for skilling and reskilling and gap detection. So it's one of the sectors in which we are more active. Apart from manufacturing, the construction is one of the sectors in which we are more active and more interested because there is a lot of room for this kind of tools. Okay. So.